Okay. Students, this is the recording that I told you that you will be receiving regarding the test paper that we did about the structure of matter. Okay. So in that, the first question says you to write the chemical symbols for some elements. Okay. In that, what you have to understand is there are uh, elements for which the chemical symbols are written with a single letter. So if the chemical symbol is indicated with a single letter, that single letter necessarily has to be a capital letter. And if there are more than one letter used to indicate the chemical symbol, the first letter has to be a capital letter and the second letter has to be a simple letter, right? Okay, so first one asks you to write calcium, right? Calcium's chemical symbol is C, capital simple A. B, the next one asks you to write about gold. Gold is A, U. C, sodium. Sodium's chemical symbol is capital A, capital N, simple A. D, silver. Silver chemical symbol is A, G. Next one is mercury. Mercury's chemical symbol will be Hg. Sulfur, then sulfur comes with one letter. The chemical symbol is one letter, that has to be a capital letter. Next one is carbon. Carbon again a single letter, which is capital C. Then next one is zinc. Zinc is capital Z and simple N. Next one is silicon. Silicon, capital S, simple I. Then oxygen. Oxygen's chemical symbol is O, right? So this is how you indicate the elements with their chemical symbols. Next one, next question, I've given you to write the chemical formulae of the compounds that I've given you. The first one is water. So for water, H2O. B, carbon dioxide. Carbon dioxide. Okay. C, capital O2. You have to be very careful when you write the chemical formula for the compound. So make sure go through your paper to see whether you have written it correctly. I saw some of the papers contained when they write carbon dioxide, they have written like this. Carbon is capital and oxygen is simple. No, this is not the way how you write carbon dioxide. This is cobalt, right? So you have to write carbon dioxide as a capital because carbon dioxide is formed by two elements by the combination of carbon and oxygen. So you have to indicate carbon is here and oxygen is also here with two capital letters, right? So this, if you write it this way, this says about another different element called cobalt, right? So never in carbon dioxide, the O becomes a simple, right? So keep it in your mind very thoroughly, right? Okay, C. C is calcium carbonate. Calcium carbonate. So in this calcium carbonate, you have calcium, carbon, and oxygen. D, glucose. You can remember in glucose, you have carbon, hydrogen, and oxygen. All the letters are capital. Next one, copper sulfate. Okay. Copper sulfate, CuSO4. Next one, sodium chloride. That is common salt what we use. Okay. Sodium chloride is NaCl. Next one, hydrogen chloride. Hydrogen chloride. That is an acid which you can find in the laboratory. HCl. Next is methane, that is CH4. Okay, so this is the set of answers for the second question. Next one, third question. I gave you a standard notation of an element like this. I gave you X, and at the base I gave you A. I gave you A, and I indicated that as 17. I gave here as B. I indicated as 35. Then my question number 1 asks what is indicated by A. Okay, question number 1 asks what is indicated by A. Guys, A here indicates the atomic number. A means atomic number. Question number 2, then I ask what is indicated by B. B indicates the mass number. So keep it in your mind every time. If you have a number at the base, left hand base of an element, that number is the atomic number, right? That number is usually taken as the number of protons. The number of protons. And if you have a number on the left hand top corner, that number is the mass number. That number is taken as the summation of number of protons and number of neutrons. Okay, so mass number can be taken as a summation of number of protons and number of neutrons, right? The third question, what is the number taken as A? Okay, so they ask what number is taken as A. Okay, number of protons. Number of protons is taken as A. Roman number 4. If the above is a neutral atom, okay, neutral atom, if it is a neutral atom, the speciality here, number of protons should be equal to the number of electrons. So it asks, the question number 4 asks, if it was a neutral atom, what would be the number of which subatomic particles would be equal? Okay, so the question asks, if this was a neutral atom, what subatomic particles would be equal in number? So the number of protons and the number of electrons would be definitely in equal numbers, right? Okay. Then the next one, fifth question. It asks what element is considered as X. So if you can see the number 17, the 7 atomic number means the number which it is given in the periodic table. The number which it is given to the particular element in the periodic table. So which element is the 17th element? That is chlorine, right? So this X is indicated for the 17th element in the periodic table, which is chlorine, right? Then the sixth one, what number is taken as B? Okay, I have given you what number is taken as B. Number of protons, that means what number is taken as the mass number. Number of protons plus number of neutrons. Okay, right. Next one. Then the next one is a fourth question. Fourth question asks you to write the types of subatomic particles, their charges and their mass. Okay, there are 3 types of subatomic particles, actually: protons, electrons, and neutrons. When you talk about their charge and their mass, protons actually have a positive charge. Electrons have the same opposite charge as proton, which is a negative charge, and the neutrons have no charge. One can say they are neutral. Yeah, true, they are neutral. And when you talk about the mass of protons, that is 1, and neutron has a nearly equal mass to the protons, not exactly same, but we can consider it to be more equal, right? The mass of protons and the neutrons are nearly equal, so we consider that to be also equal. But the thing is, electron, mass of an electron is 1840 times smaller than the mass of a proton. So 1 over 1840th of a proton. Okay. So guys, mass of an electron is 1840 times smaller than the mass of a proton. So we consider it to be a negligible mass. Negligible mass. But to be honest, electrons have a mass. We will talk about these things in detail when we come to the formation class. We have to, because these are very major facts in grade 10, right? So we will explore these things, we will understand, we will break down these things to few steps, and we will understand them properly in formation class. So keep it in your mind, the mass of an electron is 1840 times smaller than the mass of a proton, right? Okay, then the question number 5. Okay, they asks you question number 5, they asks you to write few physical separation methods and the applications of these physical separation methods. I can give you few, right? I can give you few. Can you remember winnowing? Right, winnowing. So guys, this is basically winnowing, right? So if you can see these physical separation methods, the grains in this equipment is thrown a little bit up, and all these heavy grains will come down again to the tray-like thing, but the less heavy dust particles are blown away with the wind. So this is how we use winnowing to separate particles from a mixture, right? So winnowing can be done for separate rice from chaff. So these are the other separation methods. Panning කියන්නේ අර දක්වලා තියෙනනේ මැනික් ගන්නවා ළමයි. right? ඉස්සෙල්ලාම gem O එක ගෙනල්ලා, right? gem O එක ගෙනල්ලා වතුර එකක බස්සලා හොඳට හොදනවා. එතකොට අර less dense වැලි ටිකයි මඩ ටිකයි ප්ලස් ටිකයි හේදලා යනවා, density වැඩි, ගල් ටික ඔක්කොම අර කූඩ ඇතුළේ ඉතුරු වෙනවා. And then use nicely and very carefully separate the other stones from gems by using the hands, right? So panning, floating on water. This is what is your amma does what this is what your amma does commonly when she is about to cook these cereals, right? She put them into water, and then some of them floats and she throw them away, and the remaining what is submerged in the liquid container will be taken to cook, right? Sifting, sifting you should have seen අපි මේව කරන්නේ අර මේ හිතන්නකෝ දැකලා තියෙනවද ගෙවල් හදනකොට වැලි හලනවා, right? So the fine grains are separated from the bigger grains of sand. So that simply it is. Evaporation is when you evaporate, when you put salt water into a container and heat it, the water gets evaporated and the salt gets precipitated. That is the method. Fractional distillation, we have to talk about it when you come to grade 11. Fractional distillation is the method used for separating crude oil at different boiling points. Steam distillation, that is mainly used for the extraction of essential oil. We'll talk about that in grade 11 as well, because we have to talk them. We talk about them in the syllabus. Crystallization, that comes with different, that comes with a little bit of technical terms. We have to know about the saturation of liquid and solubility of liquids. We will talk about that also in grade 11, right? So that is simply done to form sugar crystals from sugar syrup. Okay. Use of magnets. You should have seen that the soil contains some black colored soil grain which is getting attracted towards magnets. So there are things which could be separated by using the magnetic property as well, right? So if you have written any of these, your answer is correct, right? The next one is, what is a mixture? What is a mixture? Mixture is a matter which contains more than one type of pure substances, right? A matter, which contains more than one pure substances is called a mixture. So this is what a mixture is. Okay. The next one, this is the answer for the 6th question. And then the 7th question, right? The 7th question, it asks you about the 2 types of mixtures with 2 examples. Okay, homogeneous mixtures. Okay, homogeneous mixtures are the mixtures in which the composition is uniform throughout the mixture. So if you take a salt solution, right? Salt solution එකේ හැමතැනම තියෙන particle distribution එක equal, so it's a homogeneous mixture. If you take air is also a mixture of what? Nitrogen, 70% of the atmosphere, carbon dioxide 0.04% of the atmosphere, oxygen 21% of the atmosphere. So here, this composition is distributed all around the atmosphere in the same way. So it's a homogeneous mixture. And if you talk about a sugar solution is also a homogeneous mixture. So homogeneous mixtures for a composition throughout the mixture is same. And then the heterogeneous mixture. Next one is the heterogeneous mixture. Heterogeneous mixture. So the composition not same throughout the mixture. So example, a fruit salad. Right? Fruit salad එකක් කනකොට හැම scoop එකකටම pineapple කෑල්ලක් එයි කියලා හරියටම කියන්න බෑනේ. Right? So fruit salad is a heterogeneous mixture. And cake mixture. Cake mixture is also a heterogeneous mixture, right? And you can say ice cream or else cement mortar. All these are heterogeneous mixtures. Right, okay, the next question tells you to draw the atomic structure and locate the subatomic particles in the atomic structure, right? Okay, so when you do that, this is the 8th question, I guess. In this question, if you can remember this, inside the atom, you have a tiny particle called nucleus. It contains protons and neutrons. So we call this thing as nucleus. Okay, and around the nucleus, in orbits, or you can call them as shells, or energy levels, electrons are revolving around the atom, right? Electrons are revolving around the nucleus actually, right? So you have the atom, and inside the atom you have a tiny part called nucleus, which contains protons and neutrons, and you have orbits around the nucleus. We call them shells and energy levels as well. In them, the electrons revolve around the nucleus, right?